We're going to look at equations, functions. This is a quick review, right? So here are the major topics. Graphing. I'm not going to deal with sophisticated situations because we are going to graph a lot of functions. Sophisticated functions, no doubt. So if you would like us to review how to graph a quadratic function and a linear function, if I hear a yes, I will choose. If I hear a no, I will move on. Or if I don't hear anything.
What do you mean by a sophisticated function?
Rational functions, logarithmic, exponential, a polynomial. Yeah, these are basically only linear. Yeah, only linear and quadratic. That's what we're looking at.
Got it.
Okay, so let's quickly look at a linear equation. Is that okay with everyone?
Sounds good.
Okay, so I'm going to start with a linear equation. Let's say 11. And it's on page 10. And that is 2x plus 5y equals 10. So when we're asked to graph an equation like this one, first, what am I asking myself? I'm going to ask myself, what is it? First, I will identify it. And I know it's linear because x and y have power 1, and there are no products. X times y equals 10, for example, is not a linear equation. Because I will solve for y, and y equals 10 divided by x, which is a rational. So this is not a linear. So powers 1 and no products of variables. So first I identify it as linear. Once I identify it as linear, I will ask myself, how many points do I need? And here's a question for everyone. How many points do I need to graph a linear equation?
2.
Exactly 2. Very good. So 2 points. Always, number 3, I always try to find the x and y intercepts. They may exist, they may not exist. I don't know. It depends on the function or equation, etc. But I have to try to find them. Okay, so how do I find the x intercept?
Do you plug 0 in for x? Or I'm sorry, you plug 0 in for y.
Yes. So this is y equals 0 and this is x equals 0. In case we forgot y, so the x-axis, it's a horizontal line at 0 for y. So that's why is y equals 0. So that's why when we determine the x-intercept, we make y equals 0. Now when we determine the y-intercept, this is a vertical line. Where? When x is 0. Vertical line when x is 0. So this is x equals 0. So that's why when I want to find the y-intercept, I set x equal to 0. For such a line, please don't solve for y. Please, there is no need. So when I have y equals 0, I just cover this. Can anyone give us x from there?
5.
That's it. Anyone has any questions? You always stop me, right? What is the ordered pair?
5, 0.
Yes, indeed. 5 for x, 0 for y. Perfect. What about the y-intercept when x is 0? I just cover this. Can anyone give us the y?
2.
That's it. And the ordered pair is?
0, 2.
That's it. And you're done. Always the x and y intercepts. And there is no need to solve for y. There is no need to use the slope. Why there is no need to use the slope? Because only for this equation you can use the slope to graph. No other equation will help. Will be graphed, or function will be graphed by finding the slope. Just the linear one. So move away from that option. Unless you're only looking for the slope, it's a different story. Okay, so 0, 2, 0 for x, 2 for y, 5, 0, 5 for x, 0 for y. connect and extend, done. Okay, so I write always on the graph, anywhere, I write what I graphed. I graphed 2x plus 5y equals 10. You can put it here, you can put it there, anywhere. Okay, let's also look at a quadratic function quickly. Because I know exactly what I assigned for you to, what I'm going to assign for you to work on. So let's say 13. So y equals x squared minus 5. We also know something called transformations. But transformations work or are useful only if we know how to graph basic functions. What do I mean by basic functions? Y equals x, the simplest linear. Y equals x squared, the simplest quadratic. And so on and so forth. 1 over x, the simplest rational, and so on and so forth. So if I know how to graph this, can anyone tell us if anyone remembers what transformation will be x squared minus 5?
It's 5 down.
Exactly. Yes. From the x squared, we subtract 5 units. Excellent. Who was that?
Brandon.
Brandon, thank you. Good. So now the question is, do we remember how to graph x squared?
Isn't it parabola 0 where the 0, 0 is the origin and it's a, like she said, a parabola?
Excellent. Y equals x squared. Now, of course, when I graph x squared minus 5, I bring down the graph 5, but I would not know where the x-intercepts are. I know that this is the y-intercept. No question, 0, negative 5, because when x is 0, y is negative 5. But how do I determine, because I know this will be the graph, but how do I determine the x-intercepts? Can anyone tell us how to determine the x-intercepts?
Put 0 in for, no wait,
Yes, you are correct.
okay.
So 0 for y, right? Y
Yeah.
equals 0. When we determine, so remember this is the altitude 0. Y equals 0. So I want to determine the points here. So 0 equals x squared minus 5, better x squared minus 5 equals 0. How do I proceed? How do I solve this? Anyone remembers?
So go x squared equals 5.
Yes, we move
We
one
have to
term
add it.
from one side to the other. We only change its sign. Good.
And then wouldn't it, you're having to take the square root and then it's plus or minus, right? To get the negative and the positive of it.
Yes,
The parabola.
because of two solutions. Why two solutions? Is because the degree,
Exponent.
yes, the degree is 2, or the exponent, the highest exponent of x is 2. If we were graphing a cubic, we would have looked for 3 solutions. 4th degree, 4 solutions. 2nd degree, 2 solutions. So that's the reason why we have to write plus or minus. But remember, the plus or minus don't come from the square root of 5. They come from here, because this is basically the absolute value of x. So many of my students say this, that the square root of 4 equals plus or minus 2. No. 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 Plus or minus comes from this side of the equation, not from this side of the equation. Okay? So careful with that. The square root of 4 is only 2, not plus or minus 2. When you're seeing this, you're looking at the equation x squared equals 4, which does give us plus or minus 2. Okay, so this is approximately 2 point something, so I'm just going to graph it. So 2 point something, difficult to plot those points, so that's good enough. So here's the graph of,
And you said that was about like what? You said it was like just basically like 2.5.
I can plot 2 point something anyway, so
Okay.
yeah. Good. Enough about graphing. So now let's look at a couple of word problems. And I'll tell you where they are. You can open the book if you'd like. Oh, I have a chat. A chat for me. Let me see. No, it's not okay. No. No. Don't waste your time. No. The answer is no. Okay. It's a waste of time. We don't need that. You're making it more complicated. You are introducing a couple of steps, unnecessary steps, and it will be way more difficult to plot or find the X and Y intercepts. Okay. I would like to look at a couple of problems, word problems. So again, if you'd like to open on page 10, because I know it's difficult for you to read here. It's difficult for me to read here. Okay. So let's look at problem 25. I'm going to copy the function, and then you can read the rest if you like, or I will anyway. So 25 on page 10. It says optimum solar panel angle. The optimum angle A is given as the function okay. X is the location of the panel in degrees, latitude north of the equator. So X, I have to take notes, is in degrees. Okay. Part A. At what angle should the solar panel tilt in Honolulu at 21.3 degrees? So when X is 21.3. It says location of the panel in degrees, latitude north of the equator. So degrees north. So how will I determine that? And again, exactly, part B and part C are the same. So I'll share my screen and show you how to plug this function in the graphing calculator. So we don't have to do this by hand. Okay. And let's...
Because this is just plugging in the X value, right?
Right. I just want to show it with a graphing calculator. So you don't have to do this by hand or enter it several times. There is no need for that. And I have my calculator up here. So in y equals, we will enter the function as is. When we start with a negative sign, we have to use the, not the operational negative, but the little negative, 0.002 x squared. Stop me if you have any questions anytime. Plus 0.924 x and minus 0.152. After you enter the function, let me know if I should wait.
Yes, 1 second.
Sure. I'll sip some water.
Okay, done.
Ready?
Yes.
Very good. So then we go to second and table. Make sure that, first of all, since we're doing this the first time, go to second and table set and make sure that the independent variable is in the ask mode. And then go back to second and table and enter what you need, 21.3. Because otherwise the calculator will not let you enter the value you want. And press enter. And that is it. So the tilt has to be 18.622. So A of 21.3 equals 18.622.
I have a weird question that's not really mathematical, but just to make sure we're answering it correctly. Would we have to have a, that wouldn't be degrees north because that's not the tilt, would it? Like, you know how you have to put the units when you put the answer?
Yes.
So that would just be the degree sign and that's it?
It would be, yes, just degrees, because it will be something like this. Right? This here.
Okay.
Good. Moving on. Any questions?
Ma'am, I have a question.
Yes?
I'm not familiar with this calculator. Is there any manual guides I can just get to knowledge of it, how to use this calculator?
Say it again, Harish. So
I'm not familiar with this calculator.
Okay.
Before.
Okay.